Mathematical induction. Step 1 jabu ndiye mzi wako jabu. Yeah, Beno is very important, Shab. Okay, so question 1. Prove by induction. Remember, induction is done in 3 steps. So let's just try to remember the steps. So question 1, let's do question A. So 1 part A. Question is 1 plus 4 plus 7 plus 3n minus 2. This is equals to half n 3n minus 1. Prove by induction. Step 1, as usual, is the easiest of them all. We prove that it is true for n is equals to 1. So step 1 is known as the base case. So step 1, also known as the base. So we can say we prove for n is equals to 1. Meaning that what we do is we just get this part, we equate it to this part, but where there's n, we substitute with 1. So we'll have 3 times 1 minus 2, like that. This is equals to half times 1, open bracket, 3 times 1, which is just 3 minus 1, like that. This gives us 3 minus 2. On the other side, we'll have half. 3 minus 1 is just a 2. This minus this, 1. Half of 2, 1. So, true. This is true for n is equals to 1. So, since it's true for n is equals to 1, we move on to the next one, which is the assumption, step 2. Step 2. Step 2 is known as the inductive assumption. So we're just making an assumption. We assume that it is true. We assume that it is true for n is equals to k. What does that mean? It's just a matter of substituting, Where there's n in our original, we just replace it what? With k. What we get? 1 plus 4 plus 7 plus, that is 3k minus 2. Brackets, this is equals to k, 3k minus 1. Okay. That's it. That's the assumption. Step 3. This is where the problem starts now. Some of you, once you just do this two, then you're like, okay, at least I'll get something. You go to the next question. So for step 3, we prove that it is true for n is equals to k plus 1. Step 3. We prove for n is equals to k plus 1. Now, this is not as easy as substituting where there's n with that guy. No. What you do is, this is a tricky part, let's pay attention. We write down the whole thing. But the first time on this part, we replace it with k. Then the second part, we replace it with k plus 1. This is what I mean. So you say 1 plus 4 plus 7, 3 dots plus. Where there's n, replace it with k. Is that okay? Then this same guy, you write it plus this same guy. This time around, where there's n, you replace it with what? K plus 1. So plus the same one, 3, where there's n, k plus 1, minus 2. Then this is equals to, this side, where there's n, k plus 1. So half k plus 1. Then we have open bracket 3, k plus 1, minus 1. Everything is okay. The key part is here. Where there's n, replace with k, like I did. The same guy, where there's n, replace with k plus 1. Meaning that you have 2 of these. Then, have you seen this guy? It's the same as this guy. Same thing, right? So what do we do? Since this guy and that guy are the same, where is that red line? We just replace it with what? This. So that you have, where there's this guy, we have half k, open bracket, 3k minus 1. We replace this plus this, which is 3k plus 1, brackets minus 2. This is equals to the other side, which is half k plus 1. Then, how can I do it? Okay, it's fine. We can have it as 3 in brackets k plus 1 minus 1, like that. So I've just replaced this with this guy, coming from the assumption. That's the whole importance of the assumption. So the assumption is used to help you prove step 3. Now our job is to make sure that the left-hand side looks like the right-hand side. Once we're able to prove that, then everything is okay. So let's expand on both sides. If we expand here, what we have? So half k times 3k, we're going to have half times 3 is 3 over 2, like that. And then k times k squared. Half k times 1 is negative half k, like that. This part will simply be 3k plus 3 minus 2. This is equals to, so let's expand this first as it is. Is that okay? That's fine. We'll have half k. So half times 1 is half. This part, this time this will have 3k. 3 times 1 is what? 3. 3 minus this one will get a what? 2. I hope that's okay. So 3 times 1 is 3, minus 1, get a 2. Okay. So left-hand side, let's group like terms. The like terms we have k squared as it is okay. We have the k and the k. These are like terms. So 3 over 2 k squared. What is negative half plus 3? Or 3 minus half. What is 3 minus half? What is 3 minus half? Don't use a calculator, use your head. What is 3 minus half? What do you mean to half? You have 3 oranges. Remove half. Remove half of an orange. What do you mean? You have 3. You remove half. There's nothing like 2 half. It's 2 and a half. What do you mean 2 half? So it's 2.5, 2 and a half, right? So this and this, it's not 2 half, it's 2 and a half. So 2 and a half as a fraction is just 5 over 2. That's 2 and a half. There's a k. Like that, Then we have this part. If we subtract these two, what do we get? 1. So we've expanded on this side. That's okay. Where it is? 5 over 2 is just the same as the same 2 and a half we're talking about. Because remember, 5 over 2, 2 into 5 goes there how many times? 2. Remainder, 1 over 2. So just 2 and a half. So the same 2 and a half we're talking about can be written as a fraction as 5 over 2. If you want, you can even write it as 2.5. It's still fine. It's still 2.5. That's the same thing. Let's do the other side. So half k times 3k, what do we get? 3 over 2k squared. Half k times 2, what do we get? K. Half of 2 is just 1. So half k times 2 is just k. Half times this guy, what do we get? 3 over 2k. And lastly, half times 1. Sorry, half times 2 is 1. The like terms is this one and this one. What is what is 1 plus 3 over 2? 3 over 2 is the same as 1.5. When you're doing fractions in grade 2, you were absent. This 3 over 2 that you see here, 3 over 2, same as, how many times does it goes there? 2. Oh, sorry. 1, Sorry. 1. What's the remainder? 1 over 2. So 3 over 2 is the same as 1.5. So what is 1.5 plus 1? What is 1.5 plus 1? You have 1.5 oranges, then you add 1. What do you get? Yes. So, in short, we're saying this 1 plus this guy will have 3 over 2, k squared. This plus this will just get 2.5, which is just 5 over 2, k plus 1. Now you see that this side is the same as this side. So what do we conclude? This is true by induction. So true by mathematical induction. Understand that step 2 is used to help you find step 3. That's how it works. That's why you miss it. Assumption is there to help you to find the step 3. Any questions? Any questions? Don't lose hope. What's wrong? You've been given a second chance. If you know the consequences of failing a SAP, then you have to work hard. Because if you fail a SAP, meaning that same course you're writing as a SAP, you have to have it for the whole semester. You write your exam in May. That's the problem. So we just have to pass this SAP. Okay, let's move on. Now, there are some other questions whereby you can just conclude by step 1. Step 1, you conclude, that's it. Let's look at such. For example, question, let's still on question 1, but part C. Question 1, part C. Question 1, part C. Question 1, part C says, prove by induction. So we have part C, question 1, 2 plus 4 plus 6 plus, so we have 2n is equals to n, open bracket, 2n minus 1, 2n minus 1. So step 1, the best case, we prove for n is equals to 1. Step 1. So it's known as the best case. We say we prove for n is equals to 1. So we just replace where is n with 1, so that we have 2 times 1 is equals to 1. open bracket, 2 times 1 again, minus 1. And that, so 2 times 1 is 2. This side, what we have? We have 1 outside. So what is 2 minus 1? It's 1, right? Now, these two are not equal to each other. They are not equal to each other. So what's the conclusion? It is not true. By mathematical induction. You don't go to step 2. As long as this is not true, you don't proceed. So we can say, since it is not true, it is not true for n is equals to 1, then the whole statement, or the whole question, the whole statement is not true by mathematical induction. Conclude there, ends there. Okay. So there are those questions. I even saw one in the OSCE in the exam, the one which has matrices, induction for the matrices. Let's do one of those. Question 9. Question 9 came. Let's start with question 5 first. We'll come back to 9. Question 5 first. Question 5. Okay, let me remove this. So induction, I think it's in 4 parts. There's one for the algebra statements, like the one we've done. There's one for divisibility. Then there's one for inequality and matrices. So these are the ones we're supposed to focus on mainly. Let's do question 5. Question 5 says the matrix is given by A. So 5, matrix A is equals to 3, 1, 0, 1. Matrix A. Prove that by induction, A to the n is equals to 3 power n. Here we have the 0, half, 3 power n minus 1, in brackets. Here we have the 1, like that. Okay. So how do we prove by induction? Understand that this is the result. Our statement is this one. This is where we're focusing on. So step 1. Again, step 1 is still the best case. We prove that it is true for n is equals to 1. So let's just say step 1, we prove for n is equals to 1, the best case. What does that mean? Where there's n, we replace with 1. What we get? So a to the power 1 is equals to 3 to the power 1. Here we have a 0. What do we get? Half, open bracket, 3 to the power 1 minus 1. Here we have a 1, like this. Then we say a power 1 is equals to, this is just a 3. This is just a 0. Here, what do we get? 3 minus 1 is 2. 2 times half. Half of 2 is what? It's 1. 2 times half is 1. Then here what we have? Is this the same as this? So it is true. True for n is equals to 1. Remember, if it is not true at this stage, we conclude that it's not true by induction. So it is true for n is equals to 1. We move on. Step 2. Let me put my step 2 here. Step 2. Step 2, we assume, we don't prove. For this one, we assume that it is true. It is true for n is equals to k. So what do we do? Where does n substitute with the k? So from our statement, we'll say a to the power k is equals to, open bracket, 3 to the power k, here we have a 0, then we have half, 3 to the power k minus 1 in brackets, here we have a 1, like that. It's just an assumption. So this is the assumption, it ends there. Move on to step 3. So step 3, as usual, we say we prove that it is true for n is equals to k plus 1. So step 3, you can write that statement. I won't write it. Please write it. We prove that it is true for n is equals to k plus 1. You have to write it. We prove that it is true for n is equals to k plus 1. Now, this is what you do. You're not supposed to show it, but you're supposed to know it. That's the thing. Here's what you're supposed to know. Where can I write it? Let me write it here. You are not supposed to show it, you are just supposed to know it. This is what you're supposed to know. Where there's n, replace it with k plus 1, like this. A to the power k plus 1 is equals to, just write it somewhere, k plus 1. Here we have a 0, half, open bracket, 3, k plus 1 minus 1, close, there we have 1. Okay. Now, it's obvious that here I've just replaced n with k plus 1. Now, the idea is what we're supposed to do there, we have to make sure that our result is this one. How do we get to this? We're supposed to use the assumption and the one from step 1. And doing the multiplication and everything, we should come up with this. If it's the same as this guy, then we conclude that it is true. But you're not supposed to write this. That's the thing. You're supposed to know it. That's what I said. So that is just somewhere else, apart from what we're supposed to do. Now, how do we get to this guy? The key is here, k plus 1. Remember, indices. If the powers are adding, it means that the bases were multiplying. So this is as good as a to the power k times a to the power 1. Is that okay? Now, a to the k we have, a to the 1 we have. So in short, we start from there. A to the k multiplied by a to the 1. This is equals to, what is a to the k? This guy here, the assumption, which is 3 to the k, 0. We have half, open bracket, 3 to the k, minus 1. Then we have a 1 here. Okay. Then now we need this guy, a to the 1. We have it as well to that side, which is 3, 1, 0, 1. Like that. So we have those two. Let me remove this. So left-hand side, the bases are the same, the powers will add. So what we get? We get a k plus 1 is equals to. Then now, these are matrices. row by column. So this row times this column. Let's do it. So this row times this column. So 3 to the k times 3. We'll have 3 to the k multiplied by 3. This times 0, we get 0. 3 to the k times 1, 3 to the k. This times 1 will get half, 3 to the k minus 1, like that. So this row times this column, 0 times 3, 0, plus 1 times 0, 0. 0 times 1, 0. 1 times 1, 1. So a k plus 1 is equals to, remember here, this 3 is the same as power 1, right? So the bases are the same. What will happen to the powers? You add. So what do we get? We'll get 3k plus 1. This will just give us a what? 0. This is where the issue is. So to deal with that part, this is what we can do. We can expand. So this times this times that. Let's see what we get. So we're going to get 3 to the k. Half times 3 to the k. We're going to have half times 3 to the k. You can't multiply these two. They're not, this one has a power, this one, other one doesn't have. Half times 1 is just negative half. Like that. Then 0 plus 1 here is just 1. Now I'll finish a lot of space. So let me do this. Let me bring it here. So we're manipulating that part. Let's see how we can break it down. Everything else doesn't matter now. So what we're going to do is, for the first two terms, what is common? 3 to the k, right? Let's factor it out. So a to the power k plus 1 is equals to 3k plus 1. Here we have a 0. For these two, factor out what is common, which is 3 to the k. If we move 3 to the k here, what remains? 1. We move 3 to the k here, what remains? Half. But remember, we still have that other half. Here we have the 1. That's okay? Let's bring it here. So a to the power k plus 1 is equals to, open bracket, 3k plus 1, here we have the 0. Okay, so what we have inside the bracket here, what is 1 plus half? We talked about it. 1 plus half is the same as what? 1 and half. So 1 and half can be written as 3 over 2. So inside the bracket there, we'll have 3 to the k, 1 and half, which is 3 over 2, minus half. Here we have the 1. Are we following each other? Or you guys are just the passengers? Where are my friends? Where?
Where there's 3, yes.
We're multiplying now. Remember, a to the k is this matrix, a to the 1 is this matrix. So this matrix is multiplying this one. So we're saying row times column. So 3 to the k times 3, which is this part. Then this guy times 0, which is just a 0. Just multiplication. Let me break it down to show what's happening here. Here, what I did is this half times this guy, we got this. Half times 1, we got this. Then I said, for these two, factor out what is common, which is what? 3 to the k. After this question, let's do the one which is in the exam. Then I'll show you how it's done. Factor out 3 to the k, which is common. You remove 3 to the k here, what remains? 1. Remove 3 to the k, what remains? Half. 1 plus half is 3 over 2, minus the half that we still have, which is that guy. Now, this part that we have here, this part that you see here, we can factor out a half because of these two, like this. This is equals to 3k plus 1. Here we have a 0. So factor out a half, like this. So we factor out a half. Remember there's this 2. That's why I'm factoring out a half. If we remove a half, this 2 comes out. What remains? Remains 3 to the k and another 3. Is that okay? minus, if you remove this half, what remains here? 1. Here what we have? 1. We're almost there. Is this okay? Just this part, is it okay? You haven't put in your glasses, my friend. Remember, 2, I've said factor out the 2, which is this one here, the half. That half also factored out. What remains here? 1. Here, if we factor out the half, this half that you see, what remains? The 3 and the 3, which is this 3 and this 3. Now, this 3 and this 3, we can now add them. So we can add the powers. So what we get? A, k plus 1 is equals to 3 to the k plus 1. Here we have a 0. So we have half. Let's add the powers. What do we get? 3 to the power k plus 1 minus 1. 1. This guy is this guy. It's true. Conclusion, it is true by mathematical induction. Ask questions where you don't understand. Because a question like this, whether you like it or not, it's coming. And it was there in the exam as well. Ask where you need to. So let's do that question from the exam paper. Question, if you have the exam paper, question 13A. It was posted in the group this morning. This afternoon, in fact. Yeah, that one. Same one. Should be this one. So question 13A, write it down, then we do it. We'll do it step by step so that we understand it. The concept is the same. You've seen it? You have it? Okay, let me remove this. Question 13A, I believe. Okay. So, proof by induction. We have 3, 0, 6. Is that a 6 or a 0? It's a 6? Okay. Okay, so this is how we can do it, eh? This is how it looks like. It has 3, here we have a 6, here we have a 0, here we have a 1, raised to the power n. This is equals to 3 to the power n. Here there's a 0. What is here? 3, like this, then there's a 1. This is what we have, right? Okay. Now, I want to show you that this is the same as the previous question. It will look like this. So, let it be matrix A. So, we can say let matrix A be equals to this guy, which is 3, 6, 0, 1, like this. This matrix. Then, matrix A to the power n be this one, which has n, which is 3, n, 3, n minus 1, there is a 0, there is 1. It's the same thing. That's a translation. To be easier this way. Okay, so step number 1 is the base case where we prove for n is equals to 1. So step 1, so we prove for n is equals to 1. So now when proving, don't use this, use this when proving. So at where there's n, what do you put? 1. So what we get? A to the power 1 is equals to 3 to the power 1, 3, open bracket, 3 to the power 1 minus 1. There we have a 0, there we have a 1. So what we get? A to the power 1 is equals to 3 there, So 3 minus 1, that is 2. 2 times 3, 6, 0, 1. So is this true? Yes. So for the first part, it is true.
So the one we need to choose for the what is the AN coming from?
That's why I'm saying that you can translate this into this. Because this one, you can't have n here because the power n is the one that you have been given this side. That's why for this matrix, it's the one that will be given power n, but for this one, I'll just name it matrix A. Yeah, so you can just translate it to be easier this way. So you can see that this matrix is the same as this one, is just the same as the one given there. So you even conclude here and say, this is true. This is true for n is equals to 1. Then from there now, we go to step 2, the assumption. So step 2, this is the assumption. So you have to write a statement to say, now we assume that it is true for n is equals to k. Then if you say that, what do you do? Where there's n, you replace it with what? The k. So that we get a to the k is equals to, open bracket, 3k, 3, open bracket, 3k minus 1, there 0, there 1. So that's your assumption. Just like that. Okay, let's move on to step 3. Now, remember what I said about step 3? I said you have to know where you are going. So you have to do it somewhere. So let's do it. So let's write it somewhere separate. Where there's n, you replace with what? K plus 1. So a to the power k plus 1 is equals to 3 to the power k plus 1. Put a 0 there. We have 3, open bracket, 3, k plus 1, minus 1, then 1. So the whole point of having this is so that when you are done solving, you will see that it's the same as this, then you conclude that it is true by induction. So now that we have that guy, let's go ahead to step 3. So step 3, we prove that it is true for n is equals to k plus 1. And how do we start it? We say a to the power k times a to the power 1. So a to the power k comes from the assumption, which is 3 to the k. Here we have 3, open bracket, 3 to the k minus 1. Here we have a 1, there we have a 0. That's the assumption, a to the k. Then we have a to the 1, which we had from step 1. 3, 6, 0, 1. 3, 6, 0, 1. So this is just matrix multiplication now. Row by column. So left hand side, the bases are the same. What happens with the powers? We add the powers. So what do we get? A, k plus 1 is equals to, open bracket, row by column, right? So 3 times 3. So 3 to the k times 3. 0 times 6, which is just 0. 3 to the k times 0, 0, plus 0 times 1, 0. This row times this column. So this guy times 3, what do we get? We'll get 3 to the k minus 1 multiplied by 3. That's what we get. Then this guy, this guy times 6, so I can say plus 6. Is what I've done correct? So that times that is that, yeah, that's fine. Then this times 0 is 0, 1 times 1 is 1, like that. Understand what I've done? Row by column, so this part times 3, this times 3 is this one, times the 3, the 1 times the 6 is this that we have here. Okay, let's see how it proceeds. So a to the power k plus 1 is equals to, this part will have 3k plus 1, like that. This side we have a 0. So now here, let's factor out what is common. What is common in this case? What is common? 3, isn't it? So we can say 3 is common. So if we factor out 3, what remains? If we factor out 3, what remains will be 3, open bracket, 3k minus 1, close bracket, plus 2, not 6. Here we have 1. Is that okay? You understand why it's a 2, right? So the 3 that we have factored out is, which one? Let's factor out this one. This one here. This 3 is still the one that we have here. Then whatever we have inside there is what we have there. There's a 6 there. We factor out a 3, remain with the 2. Let's see how it proceeds. So a to the power k plus 1 is equals to, so 3 to the power k plus 1. Okay, let's see how it goes. We have 3 outside, open bracket. So this times this 3 times this 3, we have 3k plus 1. This 3 times this 1, what do we get? 3 plus 2. There's 1 there, there's 0. Look at what I've done. So this 3 times this 3, we'll have 3 to the k times 3 to the 1, which will just give us 3 to the power k plus 1. This 3 times 1 is just this 3. The 2 is still there. Okay. Let's move on. Let's bring it here. This is supposed to be like this. Yeah. Because remember, we factored out from the 6, so this 3 will affect even that 2. This 3 affects that 2. So make sure the bracket is like that. Okay. Let's move on. So a to the power k plus 1 will be equals to, open bracket, 3 to the power k plus 1. So down here now, what happens? We'll see that this and this, if they add, what do we get? A negative 1, isn't it? Negative 3 plus 1, what do we get? Negative 1. So we'll have 3 outside, open bracket, 3 to the power k plus 1. Negative 3 plus 2, we just get negative 1. We have a 0 there, we have a 1 there. So this is hence shown. So we conclude by saying this is true. This is true by mathematical induction. Any questions? Any questions on this one? Straightforward. So are you sure if I give you a question similar to this, you'll get it correct? By the grace. Okay, so that's how we do the matrices. Okay, let me just remind you on how to do the ones for divisibility. Let's just do those ones, then we can conclude for today. Question 2. Let's look at question 2. Just do 2 examples. Question 2. So this guy that I was writing here, this is just to help you see that it will be the same as what you had originally. You're not supposed to write here. Question 2 says, prove that, so 2 part A, prove that 9 to the power n plus 2 minus 4 to the power n is divisible by, prove that it is divisible by 5. Prove that it is divisible by 5. Question 2, part A. Go ahead, do your step 1. Replace n with 1. What do we get? Replace n with 1. What are you getting if you replace n with 1? So step 1, we prove that it's true for n is equals to 1. Step 1, as usual, we prove for n is equals to 1. So we say 9 to the power 1 plus 2 minus 4 to the power 1. So this is 9 to the power 3 minus 4. What is 9 to the power 3 minus 4? 7? 7 to 9. Minus 4. So 7 to 9 minus 4, which is 7 to 5. Can 5 go into this number without leaving a remainder? Can 5 go into this number without leaving a remainder? You're doubting? It can, right? So since 5 can go into this number without leaving a remainder, then we say true for n is equals to 1. If you find a number such that 5 cannot go into this, if it gives you a decimal point something, and you say it is not true for n is equals to 1, you conclude there it's not true by induction. It ends there. But since 5 can go into this number without leaving a remainder, then it is true for n is equals to 1. Step 2 is the assumption. Now, the assumption for divisibility is a bit different. Let me show you how it's done. So we assume that it is true for n is equals to k. So we're assuming that it is true for n is equals to k. There's a concept I want you to understand. Just a small concept I want you to understand. Think of any number you can think of. Don't tell me, just a small number, any number below 5. You have it in your mind, right? That number that you have in your mind, multiply it by 5. You have your answer? The answer you have, is it divisible by 5? It is, right? Why? Because you multiplied by 5. So if you think of any number and then you multiply it by 5, that number will be divisible by 5. For example, if I say I've chosen 3, multiply this by 5, what do we get? 15. 5 can go there. 4 multiplied by 5, 20. 5 can go there, right? So the number we're thinking of, it can be any number. So we're going to say the assumption will be that Since we're assuming that it's true, we can say 9 to the power, where there's n, we put k plus 2 minus 4 to the power k is equals to 5m. This m is representing any number that you can think of. So that same number that you can think of multiplied by 5, you still get a number which is divisible by 5. Why are we doing this? Because we are assuming that it is true. So this m represents any number. So you can also put that statement and say where m is a member of positive integer. So it can be any number, any positive number you can think of. So because of that positive number you can think of, it makes that statement true, because we're saying it's true. We're assuming that it's true. So as long as you can multiply it by 5m, then it's true. From there, we go straight to step 3. Now, I'll show you how you use step 2 to answer step 3. So we prove for n is equals to k plus 1. We prove for n is equals to k plus 1. So this is what we're going to do. Remember this. Bring in the original statement. Where's the statement? This one. Where there's n, replace with k plus 1. So we'll have 9 to the power k plus 1. Nine to the power k plus 1 plus 2 minus 4 to the power k plus 1. So this is how we're going to use the assumption. From the assumption, this part here. So we can say from the assumption, let me write the statement. From the assumption, 9k times 9, 2 minus 4k is equals to 5m. I've just separated this part. Remember, the powers are adding in the basis of multiplying, which is that. I want to make 9 to the power k the subject of the formula. This is how I'm going to do it. I'm going to say this is as good as 9 to the power k times 9 squared is what? 81. Minus, let me say this is equals to 5m. This 4k will cross the equal sign to become positive 4 to the power k. Nothing confusing. Look at what I've done. 4k goes to the other side, becomes positive. 9 squared is 81. I hope that's okay. Then from there, I want to get rid of that 81. What do? I say divide both sides by 81. Divide both sides by 81. This cancels. So 9 to the k is equals to 5m plus 4 to the k divided by 81. Why are we doing this? Because here where there's 9 to the k, we want to come and replace it with the assumption. Just a minute. Okay. So now let's bring back this guy. What we have here will be 9 to the k plus 3 Remember, 1 plus 2 minus 4 the k plus 1. That's what we have. Are we moving together? Judy, you're lost. Very lost, I can tell from the face. Let me just rewind a bit. So, assumption. We did the assumption, we forgot about it. We prove that it's true for n is also k plus 1. So, where there is n, we replace with k plus 1, which is this part. Then I said from the assumption, this part, k plus 2, is the same as k to the 9, 9 to the 2. We separate them. So I want to make k to the 9 the subject. So what do? This guy crosses the equal sign, becomes positive. 9 squared is 81. Divide both sides by 81. 81 goes there. So 9 to the k is given by this expression. Now I've gone back to this part where we said this is the same as 9 to the k plus 3, 4k plus 1. Then I want to separate it by saying 9 to the k, 9 to the 3, minus 4k plus 1. Then here, where I have 9 to the k, I'll bring this guy. So that we have, where there's 9 to the k, what do we put? 5m plus 4 to the k divided by 81. Not minus, but times 9 to the power 3 minus 4 to the power k plus 1. So this guy that you see here, this one, has just replaced 9 to the k from the assumption. It's not even confusing. You guys are just tired and hungry. Okay, so like I said, the assumption guy comes there, so times 9 to the power 3. So remember 81 is the same as what? 9 to the power 2, right? So that statement can become, let me bring it here, 5m plus 4 power k divided by 9 squared multiplied by 9 to the power 3 minus 4k plus 1. Look at what will happen now. Since 9 squared, we have 9 squared here, the 81, right? Here we have 9 power 3. So the square can cancel with the square. What remains here is just a 9. So this becomes 5m plus 4 to the power k, in brackets. What remains here? 9 minus 4 to the k times 4 to the 1. Divisibility has some process, but you can follow it if you just go through the steps. Okay. So for us to prove that it's true for k plus 1, we have to make sure that throughout we're able to factor out a 5. Because if you factor out a 5, it means that it's divisible by 5. So you can have 5 multiplied by anything inside the bracket, then the statement is true. Because we're looking for divisible by 5. Can we factor out a 5? Can we factor out a 5? Not yet. So 9 times 5, 45. 9 times 4 to the k. It will be 9 times 4 to the k. They're not like terms. Here we have 4 times 4 to the k. 45m plus, here what is common? 4 to the k. What remains? 9 minus 4. What do we factor out? 4 to the k. What is this minus this? 5. So 45m plus 5, 4 to the k. Remember, this minus this is just 5 times 4 to the k. 5 can go into 45, 5 can go into 5. So let's factor out the 5. If we factor out 5, what remains here? 9. Factor out 5 here, what remains? 4 to the k. So we have managed to factor out a 5. So since we've managed to factor out a 5, it means that this is true by induction. This is true by induction. Any questions? Any questions? The silence, is it that it's complicated or you've understood or you're hungry? Or everything mixed together? Okay, we're done for now. I'll send you the solutions for everything. Go and eat your shima with eggs. I'll send.